The next very important topic is the methods of separations of lanthanoids. We know very well that due to the lanthanoid contraction, the size of all the lanthanoids elements are almost similar. So it is very difficult to separate the lanthanoids by using a single process. So out of these many difficulties, some methods are useful to separate the lanthanoids. Among these, the few important methods are: number one, by change in the oxidation state. We can separate few lanthanoids by change their oxidation state. Repeated fractional crystallization. We can also change all the lanthanoids by form their crystals, but we have to do the process repeatedly. Number three, by fractional precipitations. We can also separate lanthanoid by the precipitations method. Next one is the thermal decomposition, then solvent extraction, and finally the most important method, that is ion exchange methods to separate the lanthanoids. The first method is the change in oxidation state. We know very well that plus 3 oxidation state of all the lanthanoid is most common and most stable. It means all the lanthanoids exist in the plus 3 oxidation state. So out of this plus 3 oxidation state, some lanthanoids also form the plus 2 and the plus 4 oxidation state. Like as cerium form the plus 4 oxidation state, and europium also form plus 2 oxidation state. So supposed to be we are having a mixture of the lanthanoids. This is the solution of the lanthanoids from cerium to lutetium. So in this mixture all the lanthanoids are present. First we'll add the oxidizing agent, that is alkyl KMnO4. It is oxidizing agent. This oxidizing agent can increase the oxidation state. We know that among the lanthanides, cerium show the plus 4 oxidation state. So it can be oxidized from plus 3 to plus 4 oxidation state. So when we add the alkaline KMnO4 oxidizing agent, this cerium plus 3 change into the cerium plus 4 oxidation state. After that, we will add the sodium hydroxide. When we add the sodium hydroxide, only the cerium plus 4 form its precipitate of cerium tetrahydroxide precipitates. And rest of the lanthanoids, which are in plus 3 oxidation state, remains in the mother liquor or in this liquid state. So after filtration, we can separate the cerium plus 4 from rest of the lanthanoids. And supposed to be this is the solution of the lanthanoids, in which all the lanthanoids are present from lanthanum to lutetium. When we add the zinc amalgam, the solution of any metal in mercury is called as amalgam, and this is the solution of zinc in the mercury metal, so it is also called as zinc amalgam. And zinc amalgam is the reducing agent. It can decrease the oxidation state. So all these lanthanoids are present in the plus 3 oxidation state. So when we add the reducing agent zinc amalgam, those lanthanoids which also exist in plus 2 oxidation state will reduced. So in this case, europium plus 3 will change into the europium plus 2, and the rest of the lanthanoids which do not exist in plus 2 oxidation state will remains in the plus 3 oxidation state. When we add the H2SO4 solution in this europium will form the precipitate of europium sulfate, and we can separate this europium from the rest of lanthanoids. So in this way, we can separate the lanthanoid by changing their oxidation state. The second method is the repeated fractional crystallization method. The lanthanoids form their crystals or solid crystals in the form of sulfate, nitrate, bromate, oxalate, etc. They also form their crystal in the form of double salt. The lanthanoid which is least soluble form its crystal very first. We know that from lanthanum to lutetium, the solubility decreases. Lutetium compounds are less soluble and lanthanum compounds are most soluble. And the lanthanoids which is most soluble form their crystal in the last. So we can use a suitable reagent to form the crystals of the lanthanoids and can separate them. Supposed to be we are having a solution of the lanthanoids in which all the lanthanoids are present from lanthanum to cerium. We have taken some of them, and when we add the solution of ammonium oxalate, because all these lanthanoids form their respective oxalate. This lanthanum form lanthanum oxalate, cerium form its cerium oxalate, gadolinium form its gadolinium oxalate. We know that, and this lutetium will form its lutetium oxalate. We know that the lutetium oxalate will be least soluble, so this lutetium oxalate will form their crystals. These are the crystals of the lutetium oxalate, Lu2C2O4T whole thrice. And we can separate this crystal from the rest of the solution. So now in this solution we are having all the lanthanoids except the lutetium which has been separated out. Now again we will add the very small amount of the ammonium oxidate. So the gadolinium oxidate, which is very less soluble, will form its crystals, and rest of the lanthanoids remains in the solutions. So after that we can separate out this gadolinium. So by adding very small amount of this crystal forming agent, we can separate the lanthanoids one by one from the solutions. So during this, the lutetium will separate out first or form will its crystal very first, and the lanthanum plus 3 or lanthanum crystals will form in the last.